Hey, testing, testing, 1, 2, 3, 4. We have a stream. Hey, welcome, welcome, welcome. Yeah, the Rust project with ECS. So, where are we up to? So, last stream, we created a player entity, and a position component. Okay. And our Rust project is starting to dream about DT. Oh, that's bad. That's really bad. If you remember, last stream I said if I had to think about something, we're probably in trouble. And, yeah, we could be in a little bit of trouble. Doesn't sound bad, really. It's normal. Code. I don't think you can see this. So this is our code base. Little bits and pieces now put together. Fully complete working program. That'll do. Yeah, that'll do. So the program just prints out a default position and a position. I did test out the default position to find out whether it worked or not, and I thought that might be a good idea. Yeah, okay, I'm alright with this. I'm alright, everything's okay. So, what do we need? Oh yeah, there's a to-do here. Oh, I've added all of this stuff, so we do actually have a goal now. Each time we run the program, represents one iteration of the main loop, and output should show the test data change each time the program is run. In other words, it should have persistence. It doesn't at the moment, it just does this default position thingy. Where's me coffee? Yeah, ECS doesn't run. It should init. Yeah, I agree with that. That should be init. And that should be init. There we go. Alrighty. We've already done a to-do. There we go. Progress has been made. Construct the game and add the ECS. I did look at that with the to-do in mind. And as we can see, no to-do here. Yeah, I'll look to it. I think we'll get rid of that one. So in other words, I'm happy with what it's doing. I'm happy with what that's doing. There's going to be a main game loop. There's no actual loop. It's just going to drop straight through. That's what these brackets denote to me. Yeah, we're going to be doing the systems today. Which means we'll probably need another component. Because I would like to do a move system. I'd like to do this. And they're using velocity, are they? Alright. That's interesting. Because all we really need to do is, well, that. Right, position. And this is why I've structured this program this way. We'll have velocity. That should do that. That should be okay there. Yeah. So all we do, yeah, is don't register it, isn't it? And it keeps putting those brackets in for some reason. Yeah, that'll do. Okay, that looks alright. I'm not bothered about this second one. So let's put velocity in here. I actually don't need that. This is going to be default. Yeah, we'll have default in here. Default, velocity. Like that. We can have velocity here. No, default velocity. Change that over. So, whinging a little bit here. Because that doesn't do anything by itself. Okay. That's fine. Get rid of all the garbage. We should be close. Expected type and found that. Really? Did you? Why would you expect a type? I think it's lying to me again. Alright, let's just check through what I've written. Everything looks okay here. We now have a new component. It's got an error. For some reason, that's an error. Let default velocity equal... It infers the type. Velocity default. And it's saying no. I've got a colon. Just remove the colon, it's easier, isn't it? Yeah, simple as that. Where's me coffee? We've got velocity, yay! So if we've got velocity, we can add that now to the player. So basically, it's this line here. Oh, wait a minute. I'm interested why it's put these two dots here instead of indenting it. Is that correct? No. Interesting. So why didn't it indent it? Fine. Add component or entity. We'll have you as a velocity, please. No, I didn't want to do that. Control Z. So we can just add velocity in. How's the sound coming through? Is it okay? I hope it's okay. I haven't checked my sound. Yeah, because I changed my sound over today. Let's have a velocity of 1. That'll do. So if I run this, it should just give me the default velocity, shouldn't it? Expression add component. That should be a comma, maybe. Maybe not. How do you chain things properly? Oh, you just don't put anything. Right, okay. Of course, of course. Oh, learning Rust is always good fun, because that's what I'm really doing. What's wrong with velocity? Cannot find struct. You want me to put it in here, don't you? You want me to use it. I don't like the way it's put this together. I mean, I didn't type this. All right. Okay. Everything seems all right now. Okay. Default position. Yeah, it says position still, so let's change that. And that's velocity. Default velocity. Just to make sure that we're actually getting defaults being placed into these things, I'm just printing it out for a debug. Nothing special going on there. Alright, so we should now have Our alteration's complete. Yeah, there you go. So I've got a position of 0, 0 as default, and a velocity of 0, 0 as default, which is what I wanted. And a cup of coffee. So it's easy to modify. It's easy to add components. Okay. So, initialize the systems. That's going to be interesting. Shall we add a system now? So that's the update. Yeah, I think we're on to systems now. So let's add a system. Mod. We'll just call it systems. Hello. Thank you. Quick fix. Create module ECS systems. Crunch. There it is. We have systems. I like the way it can generate files for me. I've come to the conclusion that I really do like that idea. What do systems look like? Ooh. Yeah. That's a component. So it's just a struct with a name. I'm very new to this language. And people are starting to call these things types. They're not the structures, the classes. It's Rust's version of a struct or class. Hey, we've got somebody in chat. Hi there. An experienced Rust developer there. Well, I'm a very inexperienced Rust developer. I'm happy for you to chip in anytime you wish. Give me some guidance if you think it's worth your while. I'm learning a little bit. I've got some idea of what Rust is doing now. This capital letter business was my biggest bugbear. Capital letters and small letters. And it looks like Rust is treating them well, because we're setting up the code that way. Rust treats them slightly differently. It looks like these are treated as types. I don't quite agree with calling them types, but anyway, that's what people seem to be thinking, and they're not. The structs. There's a big difference. So I don't agree with the convention of calling these types. That's just one thing I better mention. Because a type doesn't have this. Yeah, you don't put an implementation onto a type. Yeah. Alright, it's a system. It's not asking me to import anything. That's nice. Yeah, move system is a type. Yeah, I mean, you're agreeing with me. And that's good. That's good. Shout out to GDBW. Thank you. Thank you. Yeah, I'm not happy with that, but okay, that's the convention. Well, we're not gonna say too much about it. I'll probably call them structs or classes or something like that, because to me that's what they are. Just Just an FYI, I might not call them types, and if you call them a type, I might not understand what you're talking about. We'll have a move system. Move systems. Do we need to pluralize that? Not really. It's only one system. We'll see how that goes. Now, according to our lovely piece of sample code, we've got a problem, but we'll look at that problem when we actually get to it. Yeah, enums are types as well. Oh god, I haven't got to enums. I'm dreading it because I come from a C and C++ background, and I know that enums are different in Rust. It's gonna be fun for me to convert my brain over to that. That's incorrect. Oh right, okay. Whether you write an impl block or not, all these things are types. Okay, that's fine. That's absolutely fine. I will attempt to associate my brain with types and structures. It's just a foreign idea to me. I'm used to them being classes. I'll be very honest with you, and I know I'm coming at it from the wrong direction. It's perfectly okay. Rust is a mindset. If you don't get into the mindset, you can cause yourself problems. And that's what I'm finding on this learning curve. The learning curve's not been that bad, really. So looking at the way that they've done the move system in this code base, we've got an update, which comes from God knows where. We then pull in our self, which will be the move system. So we'll do that. We're going to be mutating ourself, but there's nothing to mutate, so I don't know why. Then we're pulling in something called a manager, which I haven't written. Okay. Which we're going to mutate. Really? And that's an entity manager. So that's being given by the library. There it is. So it is there. Then we've got an accessor. Really? Okay. Guess that's query. Okay. I find this kind of stuff, it's the same idea as in C++. Yeah. In C, instance structure types. Yeah. Sort of. Yeah. Can you paste a link to that GitHub page? Go to create.io and just type in ECS Rust. So if you go to create.io, type in ECS Rust. All I did was choose the first one and the repos there. So it's pretty easy to find. And I just took it at random. So I don't expect anything from it, put it that way. Alright, what's this accessor? Do 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 do. Here they are. It's an accessor. Alright. mute. Entity ID accessor. Alright. But again, this is coming from... There it is. This is coming from the... the library, the crate. So... yeah, I'm just experimenting. I'm learning more about Rust rather than the crate. Although you're going to find out very, very soon this crate has got a limitation which... foreshadowing. I've called it DT. I'll explain that later. Being an experienced developer, you'll know what DT is. So you won't be confused by that little thought coming out of the Rust project there. Now, I haven't written manager, which is an entity manager. I haven't written entity ID. Oh, he's put it in, has it? So it's use ECS. Yeah. What about this one? Oh, import system then. ECS Rust system, please. There we go. That's lovely. So we've got our imports now, or use thingies. Imports in other languages, I guess. And yeah. None of this I've written. Can you see a problem? I'm going to ignore the mute self bit. I'm not sure why it's there. I think it's just so that we make sure that we're only having one instance of... yeah, we're just using this instance as a single instance. Okay, that's fine. These two things, where the hell are these coming from? Well, I've got a clue in that we've only actually created one thing, and that's a world. So I'm guessing that world is a structure, and inside that structure is an entity manager and an entity ID accessor. That is then being passed through to this system, and it's part of the library. Okay. That's my basic understanding from what we've learnt so far about structures when we created the ECS structure in the last well, in our first stream when we started Rust. We seem to have gone head deep into this stuff, but that's okay. What's the purpose of the move system type? The purpose is to implement it, as we are going to be registering our system in our ECS. So we've now got our move system type. I'll show you what I mean. So this move system, why do we have this struct at all? Well, that struct is so that we can not initialize, but we can initialize the systems. I've called it initialize, okay. We'll call it initialize. So, create entities and components, blah, 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 blah. Add systems to the world. So here, we can add our systems. So it's a world thingy. So we've got a self, which is our ECS. And then inside our ECS, we've stored the world. We created a new one. Not a default, but a new one. And we popped it in. So, let's have a look at that. Basically, we've got self, world, and then we've got, I'm just going to return it, dot add system, and that's why we needed that structure. Interesting, huh? So we can just type it in here. The implementation is what we're going to run. But when we're adding a system, we add it by, well, as you say, type. Alright, let's try that. Add move system. I'm not adding any. Am I adding another system? Yeah, we will be doing later. And of course, cannot find value move system in this scope. It's gonna be asking us to do that, so we're just gonna call it systems. I don't like that, so we're just gonna put in systems. Why can you not find that? Because that needs to be public. So does that. There we go. No, that's not the bit that needs to be public. That's the bit that needs to be public. Probably. And it doesn't like the idea of me making that public for some reason. Unnecessary visibility. What? Okay, because we're not using it probably. We'll see about that. We'll see. If it says it's unnecessary, I believe it. So there we go. That's happy now. That's happy-ish. Well, will be, hopefully. So when we add a system, we've got an add. We'll see how that works out later. We might need to make that public. But it's, yeah, public and private. That's going to be fun. Update all ECS systems. We can actually probably put this in. That's no longer a to-do, we've done it. Alright. So let's put an update in. So it's going to be a public function. I know it's going to be a public function. Update. It's going to take in and mute self. Probably. We're just going to put in and self for now. Let's see if it starts complaining at us about we want to mutate it. So each time we update our ECS, we're just really going to say self world update. That's it. Yeah, does need to be mutable. Alright, that's not used. Update all the ECS systems. Here we are. Let's do the to-do. And that will just be ECS. Update. As simple as that. Alright. That's now being used. Everything seems hunky-dory there. So that part has gone through. This has stopped complaining as much, but we've still got this manager and accessor. We're now using this. In some form or other. Huh. We need to kind of write this a little bit, don't we? I don't like the way the line doesn't fit on the screen all at once, but hey ho, I've got it in large type for streaming. Sorry about that. Yeah. We've now got systems. What can we do with these systems? Well, we can access, we've got an accessor, and we can manage our entities. Or can we? I mean, this is an interesting crate, a very interesting library. I'm just confused about why they've gone to the trouble of adding systems to the world and then updating the systems once per game loop. Why have they gone to all the trouble of coding that in? When really, all they needed to code was an accessor, a query, how to query your entities. You can now start to see what I'm thinking about. This move system is on an island in the middle of nowhere. We don't have direct access to this system. This system is packaged up, stored away inside of our ECS, put to one side, and then updated when we ask it to. We've got no direct access. And as soon as I see something like that in a library, I know there's trouble ahead. One of the ways we could access it is by developing an event system that fires off an event that this system then picks up or listens out for and then acts on that event and that information inside of the event. That's one way of doing it. So we'd need an event system. Okay, that's just complicated things. I mean, if you're writing a game, you're going to have an event system anyway. So does it complicate things? I'm just wondering why it's been done this way. I'm not used to that. Normally they're open. They're open, or they have resources. Huh. And you can assign a resource that it can access, like a global resource, which you could then store things in, that can then be accessed, and information can be moved from system to system through resources. It's a type of event system, I guess. But not quite. Yeah. I'm thinking of the future of this system and how it can be used. And just looking at the signature. Yeah. Alright, we'll go into that more then. Because this is a problem. Looming. Yeah, I can see why the Rust project is now thinking about DT. Because DT is very, very, very important in most games. Especially anything with animation in it. Okay. Let's carry on with this sample program. We've split it into a separate area. We've got ourselves in a separate file. You're probably wondering why I'm bothering to put them in separate files. It's so they're transportable. You can just dump those files into any project, and the project will then use the ECS under the guidelines of main. So all we'll need to do in our project is add these lines. We'll have to add 3 lines of code. Wow, we've actually boiled it down to 3 lines of code now. All right, and literally you just copy the files over. And then you can work on those files to make them more specific to your application, obviously. You'd also have to add the crate, I guess. Can we make this work? Well, yeah. It's interesting, though. Right, let's have a look at this next line. To me, this is where it starts getting interesting. Because this is the kind of thing that I'm looking for within an entity component system. Entity IDs, okay. So now we're sort of learning more about the library than we are about Rust. Okay, that's fine. We'll take our accessor. We're going to find out what it can do. It can borrow IDs. This is what options have given us. Borrow IDs for pair. Borrow IDs for quad. Borrow IDs for triple. I wonder why they specified 3. Into, try into, format, and type ID. Okay. So that tells me that we're limited to pairs, triples and quads. That's an interesting choice. We're going to use a pair. It's already given me a vector of IDs. We know from the last stream that IDs are U size. Well, that sounds right. And it's looking for a manager. Okay. We have to tell this what pairs we want, I think. So we'll have our two components that we've made. Yeah, about that. You see, it's done it again. It's specified velocity. I don't really want it to. I prefer that. Which means we need to put in components here. Like that. And components. Why did it do that? There we go. Components. Position. Thank you. So that's right. Because otherwise it's going to put a use velocity, a use position, and you're going to have like 50 components, so you don't really want it doing that. We can only access up to 4 at a time. Alright. Oh, we've got one of these things. Oh, we've got something new here. Yeah, we're going to unwrap it, are we? Okay, it's telling me that we're going to unwrap it. What does that mean? It means it's going to unwrap into a vector of U size. Okay, so it's changed this. Cool beans. I like that idea. I've come across unwraps before. That's part of the language, isn't it? Huh. It's an option. And if we unwrap it, it becomes a vector. I see. I'm not too familiar with options. I know they exist. What does that really mean? Okay. That takes the option away and returns as a pointer to a vector view size. Ugh. Options, options, options. I'm interested. It's piqued my interest. What does that actually mean? I'm going to investigate that a little bit because I'm uncertain. So, option. Enums and pattern matching. The option enum and its advantages over null values. Error handling. Controlling how tests run. Lifetimes, generic data and enum definitions. We can express the abstract concept of an optional value. Here we go, option type. So this is coming under flow construct, control flow. We don't typically use curly brackets. Yeah. If you want to run multiple lines of code in a match arm, you must use curly brackets, and the comma following the arm is then optional. Okay. Don't think that's what it's about. Maybe I should look more on... here we go. Matching with option T. Out of the sum case. So sum option... Oh, I see. So it's the sum option. Yeah, it's starting to make sense about the words it's using. But what are they actually doing? It can return different values. Returns the contained sum value consuming the self value. Because this function may panic... Oh, really? Its use is generally discouraged. Instead, prefer to use pattern matching and handle the non case explicitly. Unwrap or default, unwrap or else. Oh. Okay. That makes sense now. Option seems to mean that it can return different states. You're not necessarily going to get what you want. I think that goes down the idea of error handling, which hasn't been done here. Okay. Fine. All right. I know a bit more about that now. So unwrap. What is it doing? It's unwrapping, or it's attempting to give us a vector of view size, but it's not guaranteed that it's going to be able to. Okay. I think that's sensible. All right. I think I need to learn more about this unwrap. I need to learn more about options. I need to learn more about sum and what it's specifically doing in the background and how the underlying code reacts to what I want it to do. Because if we're going to need to do error handling, shouldn't we be doing error handling here? Okay. Let's see. We'll have a variable to ID. Okay. In entity ID, we need to iterate through them one by one. That sounds okay. Alright. That makes sense. The use size comes up. Iter. An iterator. That's basically going to go through each individual use size in the vector in a for loop. Yeah, that's straightforward. This concept is in quite a lot of programming languages on for loops. Some people use an index, some people use an iterator. That's not a bad thing. That's okay. That works for me. So let's we can pull out the velocity and the position now, can't we? So we'll pull them out into variables, which will be vector 2s, maybe? I'm guessing, because there's two. Two floats in each of these structures. So that sounds okay. Let's we want the position to be mutable, so we'll put that in. That makes sense because we want to change the position. It's a move system, for God's sake. And this is going to be equal to this manager thing again, is it? Okay. We've got this borrow component pair again. So it's going to have to be mutable, isn't it? Now it's asking us for the entity ID. That's interesting. We've got that. That's the ID. That's borrow IDs for pair. That's borrow component pair. So it is totally different. Okay. Think that's what they're doing. Let's check. Velocity and position, we need to add that in. Okay. This line gets a bit long. Wow. And according to this, we have to dereference it? Okay. Fair enough. And we're going to have to unwrap it. Bit of a complicated line to understand, but that's fine. We're going to have velocity. Components velocity. Components position again. You can see how this is getting a little bit verbose. Is that a good thing or a bad thing? Not sure. Probably a good thing. And then we're looking to unwrap this. Unwrap it, please. Because we've got this error thing going on again, I guess. Or something similar to it. A little bit verbose. Okay. I'm going to go with it. I'm not going to question that too much because I actually understand what's going on. This ID, it wants to reference it. And we had it as a reference. Did we? Yes, we did. That's okay then. It's working alright. That's a hell of a line. Okay. I'm trying to understand each line as I type it in. See what is understandable, what isn't understandable. How much of knowledge I need to gain to use Rust effectively. This looks actually okay. A bit verbose, but okay. I mean, I learned quite a bit last time. We're learning today about types and things, that people expect them to be types. So, things are becoming clearer, bit by bit. Now we've got our velocity and our position, which is changeable. we can act on that information. Yeah. Makes sense. Position. Yeah, it works. Plus equals velocity. Yeah. Obviously position dot y plus equals velocity. It's obvious what we're doing now. We're adding our velocity to our position. That will change our position to be where we're supposed to be going. Anybody who knows about vectors knows that we've just done vector addition. Two-dimensional vector addition, but vector addition it is. There we go. Alright. Why haven't we used position? Variable does not need to be mutable. What? If you say so. Okay. Because it's here. So both of those are mutable. Now in the move system that they're giving us, they didn't put that in, did they? Yeah, they did. So this is wrong. Please don't tell me that the sample code is wrong. Okay. Yeah, they did put mute in. Interesting. So we're deviating away from the sample code at this point because we're being told to. Doesn't mean that what we're being told is correct. But it makes more sense. Yeah, you see, mute. Huh? I see. So it's actually put it in for me on the highlighting. So yeah, according to what I'm seeing here, this is actually correct. This isn't. Okay. Interesting. Will it work? I can't access position though. Outside of this system. Bugger. I can't go here and say, hey, print out entity's position to here, into the terminal, so that we can look at it and see what it says. We'd have to do that within the system. I can see that this is very restrictive. The way this has been designed. Okay. To do debug. Please, don't like doing this. Please remove this code. Debug end. Yeah, we'll do it that way. Print line. I'm just gonna put in. I'll stick a backslash in because we can. Final. Final position. This is going to be interesting because we've got an unwrap. I wonder if it'll accept this. And it's going to be position X. Oh, it doesn't exist here. We've got one of these curly braces which destroys that variable. So we can't even debug here. Alright. So we actually have to debug here. Interesting. So, print line. Coding. Yep. Certain things can and cannot be done. So, final position. We'll just print it out. We don't really care that much. Comma. Position. Dot X. And position. Dot Y. I just want to know what's going on. Really? So we can just do that. Yeah. That'll give us an idea that something's happening anyway. Does that work? Do you think? It's not saying we've got any errors. We haven't got exactly what it's told us to do. I'm just going to run it through Clippy. Clippy says we're alright. Alright. We're going to run it. Final position equals 1112. Is that what we expect? It is. We set it to 1011. We've added the velocity of 1. Final position equals 1112. Huh. Got too many spaces here. Ba 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 boom. It's worked. I'll pop one at the end for now. Just for spacing in the... So there we go. We have designed and developed a system. Or systems. Interesting. What is all of this up here? Systems, yeah. Entity manager, entity ID accessor, our components. I'm not sure we need this many spaces going on. Just cleaning up. That's better. That's made it more manageable there. Yeah. It's altered. Oh, it's done all of this stuff with this, has it? Okay. That's alright. Borrow and unwrap. Borrow and unwrap. It's separated down on the lines. Yeah, I like what it's done. I like the way it's formatted. I like that. That's good. It now tells I don't have to go across as much. Oh god. It's still a little verbose, but when you break it down into the separate parts, it's not as bad. Yeah. Well done, Rust. Okay, our ECS hasn't really become any more complicated. You see, this oh, wait a minute. This debug we could make into a system. I don't think it's worth doing as a system, but we could have a print position system. Why did it just move? I don't think it's a valid use of systems, but we could separate that off into a totally separate system, which we could delete at any time, obviously. Yeah. Okay, that would work. I like that. But any game programmer that's looking at this system will tell you straight away that there's a problem with it. Especially if they're trying to, say, move your character around the screen, or in Pong, move the bats to bat the ball. Or in Breakout, move your bat to bat the ball, you know. And the problem is that when you move something in a program, you're going to be rendering that to the screen. And when you're rendering stuff to a screen, you don't know how long it's going to take. It's not a constant. It's variable. So we came up with this idea, us lovely programmers, of delta time, DT. So each time we go through one game loop, we measure how long it takes in milliseconds usually. You can probably do it in nanoseconds, but milliseconds usually. We're aiming to get one game loop to about 10 milliseconds, between 10 and 15, maybe 16 milliseconds. So we get 60 frames per second. But we don't know exactly how long a frame is going to take. So we measure out delta time. And when we come to add the velocity of any object in the game, we multiply that by delta time so that the velocity is velocity per second. We don't actually use velocity as a value. We use it as a base value and turn it into velocity per second. How do we get delta time in here? And this is correct with red squigglies. So that's what we should be reading if we're doing a game that's got any form of animation in it, like moving a player around the screen. How can we pass delta time into this system? That's just a system type. There's no room for any optional variables. Okay. The update is just self, which is world. There's no room for any variables. It's all automated for us. The answer is we'd have to have delta time as a global. Can't add delta time as a field in move system. Yeah. I do read chat, by the way. We can't. This is fixed. This part here is fixed by the library. Remember, I didn't put this in. I didn't put this in. We'd have to have a global variable called delta time. That's one option. We can't add it to here because we didn't design this bit. This is what's being given to us by the library. We could struct move system here. Got you. But then how do we access it? Yeah. Yeah, I know you're really trying to help. It's okay. Don't worry, I do know. Alright, I like the idea. So what you're saying is put delta time in like this. That structure is accessed like this. I'm just following it backwards to see where if I can update delta time. We never initialize move system. This add system initializes it. What is this doing exactly? This is my code. This is coming from index of crates, ECS Rust 0.0.4. Okay, it takes in the type. And it pushes it into a box of systems and it initializes it here. In the library, inside the library. There's our entity manager, and there's the two things it's giving us. So it's initialized those. We can't access those, they're not public. And we don't have an accessor to a system, so we can't access it. A trait is just a definition. Yeah, but we're not initializing it. This isn't my code. This is the library that's been given to me by crates.io. And we don't have access to a component or a system. Yeah, will it be in my code though? That's really what I'm thinking. Let's have a look. I'll follow what you're saying because it's an interesting idea. Get rid of that. Delta time. Well, yeah, we're just calling it delta time. Okay. Do I really want it to be an I-32? Who cares? Right, we'll just keep it as an I-32. That becomes self dot delta time. Okay. Multiplied by. Why, what's this? F32. Alright. It's inside the add system. Ba 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 boom. We can possibly get around that. Alright, let's see if we can get around that. Okay, we got around that, did we? No. Yes, we did. There we go. So we get something like that. How do we update delta time? Go back to the error you're fixing. I mean, I've got a default value in there, it equals 0. Delta time now equals 0. How do I update it? It's inside of here. Add systems, move system, data, time, delta time, yeah, 0.1. Okay. Remove the default and take a bit more time to understand the error. So if I set delta time to 0.1, How do I then alter it? It's a variable, it's not a constant. I have to update it in here. Update delta type goes there. It's the only place we can update it. Yeah, that's okay. We're passing in an instance of move system, not a type. Yeah, I know. That's what I'm saying. This creates an instance of move system with default values. That's the problem that I've got. Yeah, I understand that it's an instance of the move system. That's not a problem with me. And I completely agree with what you're saying. But at the same time, how do I write this line here? Got a random ECS, it's not well designed. Yeah. There's that. It's the world that's the problem. The design behind how they've done this. This is not designed with animation in mind. So what's happening here is we've got a conflict of interests between what I possibly want to do, I'm not saying I want to do this, and what our library allows us to do. Our crate. You see, if I remove this, it means we've got no animation. That's fantastic if you want to do a board game. Not a problem. If you want to do an application that doesn't use animation, you're fine. You're absolutely fine. If you want to program a chess game, you've got no problem. Get something from this, but it's a pretty random approach. Oh, yeah, I know it is. That's on purpose. So what we've found by doing this development sandbox is that we don't always get what we expect to get. And GDBW has been absolutely spot on. We've chosen a random crate, we've looked at it, and we've come to this problem, which is absolutely fine. It's not a problem to me, per se. It's just Do I really need semicolon? No. No. Huh. Do I? So this isn't possible under this crate. That's awesome. Right, just get rid of these errors. Right, those errors are gone. Don't want a default value anymore. There we go. Now what's wrong with you? You struck literal. Okay. There's something not right in here. That's right, yeah, use a struck literal. Okay. There you go. Done. Done, 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 done. Make sure it runs. Yeah, it runs, it does the correct thing. That's fine. Yeah, so that's an interesting side effect of doing this development. It's forced me to understand, if I design my own ECS system, this could present a problem. By embedding everything into your library and not allowing for any kind of bypass. You see, I'm not used to this kind of idea. Whoever designed this crate, kudos to them, well done. You did some good programming. But you've also designed a crate that can't do animation. I'm guessing that that's been done on purpose. This is the correct solution. So what would I do differently? You see, what is actually missing here? Let's go here. One implementation, no. Can we go anywhere with these? No. What I would have done differently is put PUB in front of those. Make them public. That's all that I would have done differently. These two things here, I'm not sure about systems because I haven't got that far into the crate. But here, inside of the crate, I would have put these two as public, giving the programmer the option of accessing them directly. That then gives you the option whether you want to add something to the systems for the world, for the automatic systems, or whether you want to directly access a system yourself. That's the only change. So it all stems from public, PUB, not being on these two variables. or types, variables, things, classes, structures, whatever they are. It's a structure, so types. These are not public, they're private. So that gives rise to an ECS system which is good, but has its limits. You are limited to the structure of the crate and the person, the original intention of this crate. Doesn't mean it's a bad ECS system, it just means it's designed for something different. Or shall I say, it's designed for limited use. Which is not bad. Not a bad idea, really. I mean, I like it. I like this ECS system. It's nice, easy, and very, very straightforward. Can I use it? Yeah. We now have a fully usable ECS layout, as it were. What we can't do is apply this to anything with animation. So that goes away. It's no longer a to-do. Fantastic. That's no longer a to-do. That's fantastic. Any others in here? Is this complete? Wow, that's complete. Hey, we're getting somewhere. World RS, that's not mine. Systems. No more to-dos in here. Player. I want to talk about that today as well. We'll come back to that in a minute. We've got to load the player. Return the player, yeah, that's done. Okay, components. We've actually... debug. Yeah, I think we're done. Wow. The only thing that's left is this save the player to a file for persistence. I think we spoke about that in the last stream, and I wasn't comfortable with what I was thinking. I did look at it yesterday. I think it's interesting though, isn't it? How you can just pick up something at random, develop a program that works, and this program can now be transported into any other program, and we can use this as a base to help integrate this crate into any other program that we want. We are missing the persistence, but at the moment I think we should do that separately. So the original goal was the output would show that the test data changed each time the program was run. If we're not saving persistence, that's fine. What we can do instead is it in the component? Yeah, yes, we can do it here, can't we? under the system. Fantastic. What we can do to make sure that we do comply with our original goal is that. Original position. Simple as. That now complies with the development of this sandbox, as I'm going to call it. But we've now got an ECS system that can be used in any application that doesn't include animation. Alright, let's run our... There you go. Original position 10, 11. Final position 11, 11, 12. Yeah, it works. It's just an interesting crate. I think that's really good. We do have to change some things in main. We now have to make a note this ECS has no provision for animation. Using delta time. We know that for a fact now. So that's a restriction. We'll give up on persistence for now because that's a completely different ball game. I think I want a different type of development environment for file input output. I don't think I want to include that inside of an ECS as yet. So the whole ECS is 3 lines long, and it works. I would like to add to this development environment a way to provide animation, but I think that goes out of the scope of this crate. So this isn't the place for that. Do like it though. I think that's very, very easy, very, very straightforward. It's given me a lot of problems to think about and things to think about in the future on how I want to go forwards with, well, developing possible games and things. Awesome, isn't it? So I know for a fact now that we can now do systems. That was what? Movement. sometimes it's better not to force things. There we go. So we have a player entity, a position component, we've added a velocity, and a movement system. And we programmed it all in Rust. There you go, my first complete program in Rust. And all we need to do to use it in any other program is you open this up, you go to your project, I think it's this one, isn't it? You go to your source and you just copy these two files, well, this file and this folder. You just copy them and dump them into whatever project you're using and work from there. Everything's already set up, all the files are set up, all the basic boilerplate code is and infrastructure is there, and then all you do is you add to your game loop three lines. Obviously then you have to develop your components and your systems. But hey, I mean, boilerplate code for a game loop doesn't take that long to do. It all depends on how you want to set your game up. Is it a windowed game? Is it a terminal game? Could probably do a terminal adventure game using this. Footy's just thought about a different problem, but how would you do an inventory? Player inventory. I'll think about that. If you were to do a card game, possible. Chess game, possible. I think it's got possibilities. It's definitely not making itself easy to think about. In the past I've usually avoided ECS systems because really they're not overly useful at times. It's a compression algorithm, that's all it is. It just compresses your data. It's nothing new. So we've added systems, huh? Am I happy with that? Have we got any more to-dos that I really have to do? I don't think I need a structure to represent a game running. I think that's doing it fine by itself. In a game you probably would have a structure to represent the game itself. Alright, we'll skip that one then. Alright. We'll format that document. That's fine. That's pretty damn simple. I think we've got it. I think we've got the final solution. Oh my god, that was easy. The to-dos here we leave in because it's debug. When you transfer it to a different, into a production environment, then you remove this, obviously. Yeah, I just need notes adding. Okay. We're not doing that. We decided. That's a separate development. Yeah, we've still got this. All right, there is still a to do. So how does that work? To do, this is really two separate actions, so split into two functions. 3 question marks. That's my notation. 1 question mark means, we really need to do this. 2 question marks means it's probably something we should be doing, or could do. 3 question marks means, hold on a minute. So there's 2 actions going on. We are creating an entity and we are adding all of these components. So that's 2 separate actions going on. A function, when you're programming, should only take 1 action. Why? Why did I put that to do in? Because functions that only do 1 action are more powerful, can be used in various ways. A function that takes 2 actions can only be used where those 2 actions are needed. It's not as powerful. It's more restrictive. So each time you add an action to a function, it becomes less usable. In this case, does it matter? Because if you create a player, you then want to add the components. So it would be the next action taken anyway. But this adding of components, is this specific to the player? Well, in this instance, yes it is. So the 2 actions can be rolled into 1. But what would happen if I wanted to create an NPC, a non-player? We'd split this, because the required components for an NPC is a generic type, may want different types or different components added depending on what type of NPC you're initializing or creating. So these 2 would be split, and that's why I've got all of those question marks on it. So you would have NPC create, and then you would have orc create, or orc add components. Dragon, add components. Bank, add components. That's not an NPC. Oops. But the same would go for items, inventory, bank. But they're more specific, so you may be able to combine them back together again. Interesting. Because there aren't a bank isn't a generic type, and inventory isn't a generic type. It's, yeah. Inventory would probably be a component, but then how would we add and remove? We can. Yeah, this brings me to a solution. Just thinking about that. A solution to this could be placed inside an event system. And now if we were using an event system, we could add items or send items through to be added. We could add delta time, we could send items through. We'd be basically creating a resource. Yeah. Or a resource system for, no, just leave it as something simple. So we can have a resource that was time, a resource that could hold on to an item, and that can then be, that would be a global resource system. Event systems are usually global by default. Global resource system. So there are solutions to this animation and accessing these updates via something else, rather than forcing it upon the developer of the crate. So the crate, as I said already, is actually quite good. But what it's shown me is ECS isn't the whole solution. It needs more to it than just a straightforward add system, update system. I think a lot can be done with this, but more can be done if you can open it up to everything else. I wonder if the developer of this crate was going to go on to do something like a resource system. I wonder. They may have had that in mind. I don't know. But that tells me exactly where we're up to with this development environment and this sandbox. That, yeah, we've got an ECS, but there are solutions that we need to think about if we want to expand upon this ECS. That's awesome. That really is awesome. I like that idea. And this now makes me think about, oh, what happens if you develop your own ECS type of thing? Well, these are things that I would now start thinking about whilst developing my own ECS. That is really cool. I've learnt quite a bit about ECS. I've learnt quite a lot about Rust, actually. I mean, the main thing that I've learnt and taken away from this is, yeah, these are types. I've got to get that into my head. And how to use this and mute thingy, which I struggled with initially, but the borrow checker and things like that. I now understand structures a bit better. We do have traits. I now know more about traits and the value of traits, especially when on a structure, how to create a default and how we can actually call it. That's the functionality. It's got a small d. That's the type. It's got a capital D. So we're going to use this types idea. So that helps me understand the language a lot better. And I think that's good. That's really been a good learning curve. It was hard in parts, but that's not a bad learning curve. I think I've got a basic understanding of Rust. Very basic. We're not talking in depth or anything like that. I like it. I like the language. I like the way it guides me through. Yeah, everything's okay. The speed of it, I don't think there's any problems with speed. No, there isn't. Let's dig deeper into what we've got. We've now got a finished product. Well, not finished. I'll have to tidy it up. Probably put some notes in there and all that kind of jazz, because I've noticed that this place is missing notes. So there is that to do. I'm interested to see the size of this. If you're going to inject this into a different project, which is exactly what I aim to do. Maybe not this crate. I'm not sure yet. We came out at 285 kilobytes. It's about 100 kilobytes higher than I really would have wanted. But 285, we've got a full crate being thrown in there. Optimizations. How does this thing do optimizations? If I just do a release build, it's compiled it. It just runs the same. Should have kept that open. Done by me. Yeah, in release it's gone down to 185 kilobytes because we're not using everything. And we can probably optimize that even more by using optimization flags, which I don't know how to use yet, inside of the cargo tunnel. Yeah. £185 kilobytes, that comes down quite a bit. I remember looking at optimizations in Bevy. So it would be in here. All right. That's main RS. Profile dev package, yeah, up level 3. Dev. I need to know how this works properly. So we can use optimization levels, and that will probably pack it a little bit better. I don't think for this size of an executable this is quite worth it, but it is something for me to consider on bigger projects or final projects. I think I need to know more about it. Get rid of that. Yeah, right. Alright. We've got something, and it works. It's just tidy up. And I can spend hours tidying this up. So I'm not going to put that on stream. We'll give that a final then. So this is going to be the final dev code. Development code. It does open up other things that we should be looking at. And that's not a bad thing. That's how you learn. There we go, final development code done. I'm happy with that. And it's not too much code. So if I want to dig through this, it's not going to take me hours. I'm really impressed with that. I'm impressed with this kind of thing. On how Rust structures everything into, well, nice, neat packages. Yeah. I think we're done. Wow. Who would have thought it? That's all it turned out to be. 3 instructions. There you go. We have a completed project. What's our next project going to be? There's a good point. I mean, we could start looking at solutions for an event system, a global resource system. We could do that. But I'm not certain that an ECS is the correct solution for every application. It's brought more questions to mind than it's answered. And I find this each time I do a development sandbox. I will take something like some sample code. I'll go through it. I'll break it down into its component pieces or modules. See how things can be structured into something that's usable, and that then starts raising the questions. I mean, is there anything that chat would like me to do? This is my next project in learning Rust. That's complete. Done. Wowzers. I think I'm a happy bunny. And if you've got this far, then you understand this crate a little bit more. And if you want to go forwards and use this crate, you know what you're going to have to do to use it. That's important. I'm just wondering, I also have to decide now, is this crate something that I want to use in the future? I wouldn't mind, actually. I wonder how we would do that. Maybe I need to research that. See, this is now starting me down a path of what should I research? What should I know how to do? I think the language isn't the problem now. I think the language is pretty straightforward. Rust itself is pretty straightforward, and as long as you program properly, you shouldn't have any problems with it. Yeah. I think we should go with that. I think we have something that's usable. Oh, with too many of these thingies. Oh, that's bad. You might think, but you didn't put DT in. Well, that's because this crate isn't designed for it. Not easily, anyway. It's designed as a basic ECS system, a springboard from which you would probably need to do other things to turn it into something that you would want to use within your own application. Yeah. So it's knowing when not to do things as well as when to do things. Sometimes a note is better than trying to create the code. I'm interested in event systems as well. I'm interested in both of those things. Just out of interest then, hold on a minute. If we're using something like SFML, that has an event system. If we're using a UI, that has an event system. You can have multiple event systems in one program. The other option is to alter the crate and then produce your own ECS system. Can do that. Make your own library out of it. Well, comically they call it extending it. Normally it's deleting stuff. That's a possibility. We could just put those PUBs in, publics, and see where that takes us. But then we'd need to make a copy of the GitHub repository, or fork the GitHub repository, and alter it separately, then hook that into here. Yeah, that's possible. Possibilities are starting to become endless. So one of the things I have noticed, may as well look at this now we've done the programming. Alright, done the programming. If I type ECS in, we've got this. And people use this. But you can see hash derived components, so they're actually using a macro. We understand this now. System, query, entity and player. We understand this kind of thing now. We can now look at the repo for it. Do you give any examples? Yeah, you do. Oh, you've got the app thing you're going on, have you? Okay, we can ignore that. Doesn't work on my machine. This has just brought me to here. This is Bevy. Where's Bevy ECS then? It's contained within here. It could be worth, I mean, it could be worth extracting Bevy ECS outside of Bevy and looking at that. (2D renderer). 3D renderer. I don't want any of the render graph. Yeah, you see, animation works. It's got UI as well. Oh. Scene, sound. Hot reloading. Yay. Compile times. Free and open source. Quick start guide. Yeah, this wasn't very useful. I've read through that. I've got a feeling I could write an example code, a sample program, and do exactly the same thing as what I've done here. I could then probably fit it in to these, altering the commands, and then we could probably split this down into doing what we actually want with everything else. Swapping this code over to a different crate should be yeah, it should be trivial. I like this code now. Okay. I need to learn more about this option thingy. I'm going to have to do some reading. Awesome. We still didn't manage our question marks, did we? Our unwraps. I need to look into that more. This code is finished as far as I know, but I've still got question marks on unwrap. I'll have to add that into some notes in here. Alright, we're done. We're done, did. I'll go away and start developing me notes, I suppose. We need to note all of this stuff like that. That's awesome. That really is awesome. On that note, I'm going to love you and leave you. Go get some food. I think I've earned it. Well done. We're finished. So, in the meantime, take care. And thanks for popping by.